This question says that find the slope and deflection at each point marked, meaning at point A, at point B, and at point C. Right? What we are going to do, we are going to solve the slope and deflection at point A. Okay, let's do it this way. Let's solve slope and deflection at point C, right? At point C, we want to solve the slope and deflection at point C. How it works? We are told that take EI to be what? 18,000 kilonewton meter square, meaning the product of Young modulus and moment of inertia. This is it, right? Now, when it comes to numerical calculation, for numerical calculation, you always need to observe something. Always observe the unit of this EI, and it's very convincing. Though it's not convincing, it's just like you doing conversion. You must be good at your conversion, right? Now, from here, what if this place is kilonewton millimeter square? You are working with meter, meaning that at the end you convert to millimeter. But don't let us bother ourselves with that. So the question directly is giving us meter square, right? Now, from here, first thing first. Given this question, you have to calculate deflection. What's your step? Let's solve for a slope. By the time you solve for slope, you solve for deflection. The difference between slope and deflection is that for deflection, you need your centroid. The slope that you've calculated before, that you've gotten, just multiply it by centroid and you get deflection. Now, in this case, this cantilever beam, unlike the previous one, it is just loaded with a point load at the free end. But in this case, it is loaded with what? A UDL and a point load. Now, you consider your UDL separately and you consider your point load too separately. Meaning, you withdraw your beam considering UDL, draw your beam considering point load. Meaning that you get the slope due to UDL, you get your slope due to what? Point load. Then you add it up to get the next slope at whatever point you are calculating. You get what I'm saying? Say you are calculating slope at C, meaning theta C. What you are going to do is that theta C, the slope at C due to point load, and the slope at C due to what? UDL. So for any point, if it is point B, same idea. If it is point A, same idea. But we already know that for A, slope and deflection is 0. Are you getting me? Meaning I can only obtain slope at B, slope at C, also what? Deflection at B, and what? Deflection at C. Now, whatever thing that we are doing here, our answer, what we got to be our answer, what we'll be getting to be our answer, solve this same question using double integration method, you must get the same thing. Using double integration method, you must get the same thing. You understand what I'm saying? This same question, by the time you solve at the end, I want you to solve yourself using double integration method, meaning the method we know already. So you must get the same thing. Given this question, if it was double integration method you are asked to solve, you'll be able to do that. Just applying the normal idea of double integration method from step 1 up to step 7. So same step, apply it. You must get the same answer to what we'll be getting now. So solution, draw your beam due to what? UDL, and your beam due to what? Point load. Your beam due to UDL, what's the value of your UDL? 20 kilonewton. This is what? 20 kilonewton. What's the value of your point load? 20 kilonewton. What's the total distance? 7 meter, right? For your UDL, this is A, this is what? C, right? For your UDL, this is A, this is C. What's the intensity? 5 kilonewton per meter. What's the total distance? 7 meter, right? Given this question, you've simplified this question. From here, it's complicated. It's cumbersome here, but from here, you've already made it simple. You've simplified. Let's say this is case 1, and this is case 2. Combination of case 1 and case 2 will give you the original question. True or false? True. Now, we are solving slope first, we want to solve our slope first, right? What's the step when it comes to slope? Draw your elastic curve. After drawing your elastic curve, draw your bending moment diagram. So from here, let's draw our elastic curve. Drawing my elastic curve, this is my beam, this is the fixed end, and it's going to deflect in this nature, right? This is B, right? This is the tangent at A. This is the tangent at A, and is what? 0. Always take note that your tangent at A is 0. A straight line, 0. Then for your deflected part, let's draw the tangent. You know, the idea of tangent is that you are just drawing a straight line with respect to the curve. So if this is point B, you are just drawing a straight line, and this is what? This straight line, not just a straight line, but what? The tangent of B. Then by time you notice, let me call this, you notice that between the tangent of B and A, an angle has been formed, right? An angle has been formed, and this angle is what? Theta B to A. Theta B to A. You can see that we are replicating what we did previously. Nothing is changing. So from here, I'm done with that. Let's draw our bending moment diagram. Our bending moment diagram, what do we have? Bending moment diagram, what do you have? For UDL, for a cantilever beam loaded with a UDL, what's your bending moment diagram? We must know it. It's something that we need to learn. We must know it. Given any type of beam, without solving, I must know the bending moment diagram. Not right hand triangle. This is a UDL. It is for this guy that you have right hand triangle. But for this UDL, it's not right hand triangle. This is the bending moment. This is your bending moment. You have your bending moment like this. This is different from right angle triangle. It is curved. How do you know if it will curve? If you have a cantilever loaded with a UDL, the bending moment will curve. It will be like this. It's a right angle triangle, but it is going to curve in this manner. But for this guy, you have right angle triangle straight. That's the difference. That's the difference. So that's how it works. That's the difference. Now from here, this is A, this is B. What will be the value of moment at this point? This is my elastic curve. This is my elastic curve, and this is M by EI diagram. How do I get the value of moment here? 5 times 7 moment. First time distance. First of this CDL is what? 5 times 7. What's the distance? 3.5. Yeah, 7 divided by 2, 3.5. Distance was 8. Yeah, taking the moment from C back to A. From C to A. The first 5 times 7 is what? That's not the first. But distance from C to A, that's what? 7 divided by 2. Okay. You're supposed to have known this now. This is a UDL, not point load. In your apply mechanics, strength of material, we've done it. It is a UDL, not point load. So from here, meaning the value of movement at this point is what? Input in your calculator, what do you have? 5 times 7 times 3.5. 5 times 7 times 3.5. You are taking the movement to this point A. You are taking it like this. So what do you have? For UDL, force times distance. The force is what? 5 times 7. The distance is what? 1 over 2 times 7. So this is 35 times 3.5. And this is what? 122.5. Is that correct? So meaning the value of movement at this point is what? 122.5 kilonewton meter. But the diagram is what? M by EI diagram. So this value divided by EI. So what do you have? 122.5 divided by EI. What's your EI? You are giving. Don't substitute yet. Don't substitute yet. Later on you substitute. So that's it. You have considered this UDL. Now for this point load, what do you have? This is the elastic curve. This is the elastic curve, right? I'm having something like this. You are just representing same thing here. Nothing is changing. Or let me say this, from here, to avoid drawing your diagram, you can just make your sketch under the same diagram because the elastic curve will not change.
It's not going to be kind of rough.
It won't be kind of rough. It's just that after drawing your elastic curve, indicate bend M by EI diagram due to what? UDL. Draw the next M by EI diagram due to what? Point load. Instead of separating like this, but for better understanding, you can actually separate like this, and you'll be seeing what you are doing. So you like it like this anyhow. So this is you are still replicating this guy. This is tan A, which is what? 0. This is theta B to A. This is tan B, right? Then from here, let's draw a bending moment diagram. For your bending moment diagram, for a simple supported, for a cantilever beam loaded with a point load at the free end, this is your bending moment diagram. True or false? True. Now, what the value of moment at this fixed edge? This is just 20 times L. That's 20 times 7. That's 140. So this is what? 140. But this is M by EI diagram, meaning 140 over EI. 140 over EI. Now, we've made this is our sketch. We've made the sketch of case 1, meaning due to UDL, this is my sketch. Due to point load, this is my sketch. Now, let's calculate the slope. What is the slope saying? By theorem 1, recall theorem 1. Theorem 1 is what? Recall your theorem 1. The angle measured in radian between the target of any 2 points on the elastic curve of a beam is equal to the area under the what? M by EI diagram. Now, the 2 points in this case is what? Case 1. What are these 2 points? A and B. Yeah. What the area? What is the A and C? A and C, yeah. A and C. And we'll be using B since morning. It is actually C. Easy. You can that's why you call your theorem. It is A and C. It is A and C. It varies. It's not all the time you have the A and B, A and B, depending on the point. That's what the theorem is saying. Are you getting me? So now from here, while the theorem says that the point in this case is what? A and C, right? Now you are calculating the area of the bending moment between these points, right? Now this is the bending moment. This is the M by EI diagram between these points. Now what's the area? Check the table I gave you guys. What's the formula for the area here? 1 over 3 times breadth times height. 1 over 3 times breadth times height. Meaning that the area is equal to the area of this shape is what? 1 over 3 times breadth times height. What is the breadth? 7. What is the height? 122.5 divided by EI. And it is equal to what? The slope at B. Are you getting me? Slope at C. Sorry about that. Slope at C. So right, not just slope at C. Theta C to A is equals to slope at C minus slope at A. And we know that slope at A is what? 0. From my theorem, from the derivation of the theorem, I said the slope at A is what? 0. Meaning slope at C to A is still the same time as what? Slope at C. And how do you get slope at C? Area of this shape. Let's denote this to be A, this should be C, this to be C, and this to be what? A prime. Meaning that A, C, A prime. Now check. What is the formula for the area of AC A prime? That's what? 1 over 3 times breadth times height. Right? Now identify. What's your breadth there? 7. What's your height? 122.5 divided by EI. Input this in your calculator. What do you have? 122.5 times 7 divided by 3. What do you have? 285 point what? 83 divided by EI. Right? Meaning theta C is equals to 285.83 divided by EI. Meaning that the slope at C due to what? UDL or point load? UDL. This is it. The slope at C due to UDL. This is it. Now, you solve slope at C due to what? Point load. By the time you solve slope at C due to point load, your answer, sum it up with this. That will give you the net slope that will occur at C for this particular beam. So it depends on you. From here, you might decide to substitute the value of EI directly and get your slope at C. You can decide it, but that doesn't mean your answer will not still be correct if you sum it up and do fraction. You get my point? Like from here, from up to this level, you can substitute the value of E and I. You can substitute the value of EI directly, which is this guy. You get your answer for the slope at C due to your UDL. But if you work with fraction, meaning if you solve this guy and get fraction and add it together, you still get the same answer. So let's just solve the slope at. Let's just solve for the area. Let's just find the slope at C, right? This is the same idea. In this case, the slope at C, to get the slope at C here, that would be what? The area of this shape. This shape is what? Right angle triangle. What the area? 1/2 times the length times what? Height. Now, meaning the area here is what? 1/2. What the length? 7. The breadth. What the breadth? 7. What the height? 140 over what? EI. Is that correct? 1/2 times the breadth, 7 times the height, 140 over EI. Now, you put this in your calculator. What do you have? By the time you do this in your calculator, you are having that the area is equal to what? 490 over what? EI. And not just area. This area means what? The slope at C. I get me? Meaning the slope at C with respect to A, which is still the same thing as slope at C. You know why, right? Is equals to, what do you get here? 490 over what? EI. Now, to now get the slope at C for the given question itself, this is the given question and not this, neither this. What we just did for exact calculation, we separated it. We found the slope at C due to this beam. We found the slope at C due to this beam. Now we've gotten our answer. Sum it up. You get this guy. Are you with me? Now you get the main question itself.
Slope of the question.
Slope of the question itself.
So if it's for supported beam too.
That's how it works. If it's for simple supported beam, so you separate, you split. You solve for UDL, you solve for point load.
If it is 2 point load.
If it is 2 point load, that's the same idea. But no, you solve questions. Meaning that the net load theta C is equals to theta C due to what? UDL plus what? Theta C due to what? Point load. Are you getting me? Now, what's theta C due to UDL? Theta C due to UDL. What do you have? 285.83 divided by EI plus theta C due to point load. We got 490 divided by what? EI. Right? Now, let's solve this. LCM, EI. What do you have? 285.83 plus 490. So that's correct. Solve this up. What's the answer? 7 what? 285.83
plus 490. With 775.83.
So from here you have 775 point what? 83. And you have been given that EI. We've been given the value of EI from the question to be what? 18,000 kilonewton meter square. So substitute 18,000. Substitute that here. So input this in your calculator. What do you have? The ratio of this will give you the slope at C for this question. Slope at C is equals to what?
0.4.
So slope at C is what? 0.0431 radian. From theorem 1, the slope measured in radian, meaning slope is measured in radian, not just 0.043, but what? 0.0431 radian. Radian. And you can also convert from radian to degree. You know, I showed you guys when we did simple supported beam for double integration method. So what I am just going to do is that Let's say you are solving OBJ, which you cannot solve OBJ. I'm just saying. Let's say you are solving OBJ and you didn't see radian. You are seeing degree. How do you convert to degree? That will be what? 0.0431 times 180 over pi. What's the answer? 2.45 degree. So 2.45 degree, right? But what's the nature of this slope? Is it downward slope or upward slope? Downward slope. Why is it downward slope? Not even because it's a cantilever, because the nature in which this beam is deflecting like this. It is deflecting in the negative axis. You know, from here we have negative. We didn't include it here. We did not include it. We have negative. This answer is negative. This one too is negative. Meaning negative 122.5 plus negative 140. It will always be negative. But they won't show it. You just know that at the end of the day, you are showing it or you are not. If you are showing it, your answer will result to negative. And if you want to do your conclusion, you write negative, you write the magnitude, open bracket, downward slope. You get. So from what we got here, meaning 0.0431 radians, open bracket, downward slope. Approximately, what do you have? 0.04. Meaning theta c, approximately you have 0.04 rad or what? 2.45 degree. Any of these, you are correct. You are correct. Can you see how it works? Can you see that it's very interesting? So using the same, by that you use I would love you to try this using double integration method. Use double integration method to do this. I've already explained. I've done video on this before. So use double integration method. Use double integration method to solve this question. At the end, you definitely get this thing. If you are not getting it, it means all this thing is rubbish. All what we've been doing since morning, we have been saying rubbish is not correct. You must get the same thing. Are you getting me? You must get the same thing. So you can just try that on your own. Now let's find the deflection.